a water main is to be constructed with a 10% grade in the north direction, 20% grade in the east direction. Determine the angle theta required in the water main for the turn from north to east. So a 20% grade, the word grade is another way to say slope. The word grade is another way to say slope. But when we think about slope, we think about it as rise over run. Now it's not a line, it's a vector, yeah, but still, there's a definite rise over run as we go from point A to point B in the north direction. See the arrow? It's very small, but there's a little arrow here on the dotted line. There's an arrow. So in the north direction, north is this way. So this angle here, I don't know, let's call it alpha. Here we have that alpha will make a 10% grade. 10% percentages does us no good. We need the fraction version of it because we can then think about it as rise over run. So we convert that to a fraction, we get 1/10. So the rise should be 1 while the run should be 10. So this distance here along the north is 10 and the distance upward here is 1. And let's just make this the origin for simplicity's sake, so that we then can think about this as like our x-axis, then we have our y-axis, and then up here would be like our z-axis. So we can actually get a coordinates for the points. Point A has a distance 10 away from the origin on the x-axis. The coordinates for point A would be 10, 0, 0. Point B is 1 above along the z-axis, 1 above the origin along the z-axis. So point B has coordinates 0, 0, 1. Okay, great. So we now move on to a 20% grade in the east direction. There's another little arrow there, it's hard to see. And so this is the east direction, there's the arrow. And so what you need to do is like create a horizontal here. Let's call this angle here beta. The beta angle there will create a 20% grade. 20% is 1/5. So we should rise 1, we should run 5 from that particular point B. Let's call this point C. So if I rise 1, my z coordinate goes up by 1. So my z coordinate should be 2. If I run, I've already got this 1 here, and now I have another 1, so that's why my z coordinate is 2. If I run 5, this distance along the east is 5. That's your y coordinate, changing from 0 to 5. But your x coordinate, it shouldn't change, it should still be 0. So we have the coordinates for the points. Now we're in good shape. It's all downhill from here. We need to get vectors and then the angle between the vectors. Taking point B as like our anchor, let's get the vector that goes from from B to A. Draw it in red here. The vector from B to A would be A's coordinates minus B's coordinates for the I, J, and K components. So we take 10 minus 0, and 0 minus 0, and 0 minus 1. And what we get out is the vector 10, 0, negative 1. Then we go get the vector from B to C. The vector with the initial point B and the terminal point C will be found by taking C's coordinates and subtracting B's coordinates. So we have 0 minus 0, 5 minus 0, 2 minus 1. Final result, 0, 5, 1. We have our two vectors. Let's call this guy V, the other guy W. Now we have them as vectors, and in essence we're just looking for the angle between V and W. The angle between V and W is called theta. Okay, we have a formula. The cosine of theta is the dot product between the vectors divided by the product of their magnitudes. So, dot product will be just multiplying components and adding to get a number. That number would be 0 plus 0 minus 1. The magnitude of V would be the square root of 101. The magnitude of W would be the square root of 26. 25 plus 0 plus 1. Alright, great. So we have the square root of 101, the square root of 26, and now we know what the cosine of theta is. So theta then will be the cosine inverse of -1, and let's take, well, you don't have to do it here, but 26 times 101, and throw that underneath a root, and yeah, go to calculator. I think they might want the answer in radians, and so you take it from there, but make sure you round it like they're asking for. I think it's to the hundredths place. And yeah, that's how you work that problem. Alright, great.